This lesson is 9.4, choosing a method for solving quadratic equations. So we've been on this solving quadratic equations unit for a while now. And we've learned how to solve quadratic equations through factoring, through quadratic formula, and quadratic equation, or I'm sorry, it's factoring, completing the square, and quadratic formula, right? And taking the square root. So which ones are we going to use? It depends on what the equation is. So the steps to it in general, we're going to make one side equal to 0. And if there's only one x variable, then we're going to take it by or solve it by taking the square root. Okay? And if there's more than one x variable, then we're going to factor or use a quadratic formula depending on what equation we have. So these are the steps in general. And sometimes we are not going to follow the steps and we're just going to solve it. Okay. All right. So we're going to go through 9 examples today, highlighting these steps. Okay. So example number 1, we have x squared minus 7x minus 12 or equals negative 12. So the first step we're going to do here is we're going to make one side equal to 0 by adding 12 to both sides. Okay, once we do that, then it's going to be x squared minus 7x plus 12 equals 0, right? And once one side equals 0, now we see 2 x variables, so we cannot take the square root. So we're going to use the x method or find special forms. So we're going to use this, we're going to solve this using factoring. Remember, when we factor, we're going to make 2 parentheses here, and the x times x is x squared. So that's how we get our first term here. Now we're going to think about 2 numbers that multiply to 12, which would be 1 and 12, 2 and 6, 3 and 4. One of these combinations gives me a sum of negative 7, right? I should put plus or minus, plus or minus. Okay. So what 2 numbers here gets me a sum of negative 7 and a product of 12? 3 and 4, but negative 7, right? So it has to be negative 4 and negative 3, right? Negative 3 times negative 4 is positive 12. Negative 3 plus negative 4 is negative 7. So we fulfilled our factoring requirements. So if x minus 3 times x minus 4 equals 0, then x minus 3 can be 0, or x minus 4 can equal 0, and we just solve it, right? So then x equals 3, or x equals 4. And those are my answers, my solution. Okay? Cool. This one, it already equals 0, example number 2. Right, so I'm going to solve it. I only see one x variable, right, which is the x squared. So I'm going to solve it by taking the square root. So I'm going to solve this by adding 64 to both sides. Once we do that, it's going to be 36x squared equals 64. And then I'm going to divide by 36, divide by 36. So then x squared equals 64 over 36. We can reduce this, but I'm not going to. Why am I not going to? Because my next step, we're going to square root it anyway. And I see that 64 and 36 are both perfect squares, right? So then we can reduce it later on. So x is equal to square root of 64 is 8. Now, once we took the square root, we're going to add a plus or a minus. Okay, square root of 64 is 8 over square root of 36 is 6. So now we can reduce this down to be plus or minus 4 over 3. Okay, so your answer would be negative 4/3 or positive 4/3. You could also just leave it like this if we want to. Okay, cool deal. Example number 3. In this case, I'm going to subtract 2 to make one side equal to 0. So then that would be 4x squared minus 4x minus 5 equals 0. I see two x variables, so I cannot solve it by taking the square root. So I have to try and factor this out. Remember, factoring, we're going to get the multiples of 4, which is 1 and 4, 2 and 2. We're going to get the multiples of negative 5, which is negative 5 and 1, or 5 and negative 1. And then we're going to try and come up with the sum of this middle term of this negative 4. Okay, so the sum needs to be equal to negative 4, right? By multiplying these guys out. So if we try it out, 1 times negative 5 is negative 5. 4 times 1 is 4. That does not work, right? It does not equal negative 4, so those two guys are not my number. Let's try another one. Let's try 4 and 1 and 5 and negative 1. So 1 times 5 is positive 5. 4 times negative 1 is negative 4. That does not work. Now we can also use this one and switch what we did in our first one. Okay, so 1 times 1 is 1. 4 times negative 5 is negative 20. That does not work. Okay, so you're going to go through this process and find out that this does not work. Okay, so then if you use 2, 2 times negative 5 is negative 10. 2 times 1 is positive 2. That does not work. 2 times, and that doesn't work as well, right? Even though I put a negative here and a positive here, it doesn't work because the difference would be 8. Yeah, I need a negative 4. So it doesn't work. So factoring does not work. Okay, we tried factoring. It doesn't work. Now what we're going to do then is going to go switch over to the quadratic formula. Okay, so the quadratic formula, we have our a value. Remember, our a value is the coefficient of x squared, which is 4. My b value is the coefficient of x, which is negative 4. And my c value is my constant, which is negative 5. So using these three as my a, b, c, I'm going to plug it into x equals negative b plus or minus square root b squared minus 4ac all over 2a, right? So then this one would be negative 4 plus or minus the square root of b squared. So that's negative 4 squared minus 4 times 4 times negative 5 all over 2 times 4. Simplifying this out, that would be x equals positive 4 plus or minus the square root 16 minus 2080 or plus 80, not minus 80, but plus 80 over 8. So this one would lead me to say it's 4 plus or minus the square root of 96 over 8. Now with the 96, we're going to simplify that, right? What two numbers multiplies to 96? Any two numbers. If it's difficult to find it, or you don't know right off the bat, you can always take out a 2. 2 times 48. And then 48 can be broken down into 2 times 24. 24 can be broken down into 2 times 12. 12 can be broken down into 2 times 6. 6 can be broken down into 2 times 3. Right? So 96 equals 2 times 2 times 2 times 2 times 2 times 3. Right? We broke it down into 2's. Now, in order for us to simplify this, square root of 96, we have to get pairs. So I see 1 pair of 2's, 2 pair of 2's, correct? So 2 2's come out, 2 times 2, square root of what's left over inside then? This 2 and this 3, which is 6. That make sense? Yeah. So 2 times 2 is 4, square root of 6. And then I'm going to rewrite everything that we have here. Okay. Any questions on what we did? How to simplify square root of 96? Yeah. So the square root of 96, right? If we have a square root of 96, 96, if we get down to if we break that number 96 down, right, into, let's go 2 times 48. That means that this can be broken down to 2 times 48, right? Yeah. And I'm going to do this until I get all prime numbers, which we did up here, which we can go 2 and 24. 24 is 2 and 12. 12 is 2 times 6. 6 is 2 times 3, right? So this, we can rewrite this as 2 times, how many 2's do I have? 1, 2, 3, 4, 5. 5 2's times 3, right? So I know 2 times 2 times 2 times 2 times 2 times 3 equals 96, right? So this whole thing has the same value as the one on top, square root of 96, correct? Now, if we have 2 times 2 times 2 times 2 times 2 times 3, in order for us to get out of the square root, we need pairs. Because pairs would create a perfect square. Okay? Meaning, what's the square root of 4? square root of 4 equals 2, right? Because 2 times 2 equals 4, which would get me a pair. Okay, we can do this with any number. Square root of 36, that is 6 times 6. So that's 6 times 6, pairs of 6. So that comes out as, we all know that the square root of 36 is 6. Correct? Okay, so we got one pair of 2s, 2 pairs of 2s. So that's why up here I have 2 times 2. Okay. And then what's left over, since this 2 here doesn't have a pair, it has to stay inside. With this 3 that doesn't have a pair, so 2 times 3 is 6. That's how I got this 6 up here. Okay, and then 2 times 2 is 4. So that's how we got 4 square root of 6. Okay. And we can do this with any number. All right. So if I have 4 plus or minus 4 square root of 6, I'm going to erase the square root or divide it by the square root of 8 first. So looking at my numerator, what can I take out of a 4 and a 4 square root of 6? What's in common? A 4. So if I take out a 4, what's left over inside is we're dividing it by 4. If 4 is in common, we're dividing it by 4. So 4 divided by 4 is 1, plus or minus 4 square root of 6 divided by 4 is square root of 6. Reintroducing my denominator of 8. Now here, this 4 cancels out with this 8, make 1 and 2. So my x value is going to equal 1 plus or minus square root of 6 all over 2. Okay. Questions? No? All right. Now going to my next one here. I'm going to make one side equal to 0. So subtract 1, subtract 1. And we have 8x squared plus 9x plus 1 equals 0. So I'm going to try and factor this out again. Multiples of 8 is 1 and 8, and 2 and 4. Multiples of 1 would be 1 and 1. Correct? Multiples of 8 is 8 and 1, and 2 and 4. Multiples of 1 is 1 and 1. So I need two numbers. When I add it, make 9. So I'm going to try this one here. 1 times 1 is 1. 8 times 1 is 8. 8 plus 1 is 9. So that works, right? So I have a 8 times 1. So then this one would be 8x times, remember, this is the times 1. And I have a 1x times 1. And they're both positive ones. Okay. So then we have 8x plus 1 times x plus 1 equals 0. So then 8x plus 1 equals 0, or x plus 1 equals 0. If I subtract 1 on both sides, then 8x equals -1. Divide by 8, divide by 8. X equals -1 over 8. Or x subtract 1 on both sides equals -1. So here are my two answers. You're always going to have two answers. Always going to have two solutions. Okay, because it's quadratic. And remember, quadratics, we're using the, it's a parabola, right? In terms of the graphing quadratics. All right. Our next one, number 5, we only got 5 more, guys. So, stay around, stick around. Already one side is equal to 0, so we're good with that, right? I see one x variable, x squared. When you see one x variable, it's always going to be x squared. All right, it might be in a parentheses, but it's still x squared. So here, I'm just going to solve it by adding 13, add 13. We have 5x squared equals 13. Divide by 5, divide by 5. X squared equals 13 over 5. Now I'm going to square root it, square root. So x, whenever I square root something, it's always going to be plus or minus. Square root of 13 over square root of 5. But I cannot have a square root in my denominator. Okay? So I'm going to multiply this by square root of what? Of 5. Essentially, multiplying it by square root of 5 over square root of 5 would get rid of the denominator, the square root in my denominator. Okay? Because square root of 5 times square root of 5 is square root of 25, which is 5. Okay? In my numerator, I will just multiply, what's 13 times 5? 65. And that would be my answer with the plus or minus. Okay? This one, it's already equal to 0, so we're good. Multiples of 7. I'm going to try and factor it. 7 and 1. Multiples of negative 5 is 5 and negative 1, or negative 5 and 1. Doing this really quick in your head, can we ever get a sum of negative 5? Can we ever make let's do this quick. Getting these two numbers here. 7 times 5, that's already too big, right? That's 35. And I only have a 1 times negative 1 left over, or a 1 times 1 left over. So I only have a 1 or a negative 1, right? If I have a 35 minus 1, negative 5 plus 1, that's not going to ever add up to negative 5, right? So 7 times negative 1 is negative 7. 1 times positive 5 is 5. That gets me negative 2, right? And that is not equal to negative 5, so that does not work. Yeah? So factoring does not work. Okay? So we're going to use the Pythagorean theorem. X equals negative b plus or minus the square root. B squared minus 4ac all over 2a. Where my a value here is 7. My b value here is negative 5. And my c value here is also negative 5. So I have x equals negative 5 plus or minus the square root of -5 squared minus 4 times 7 times -5 all over 2 times 7. Okay. And then we are going to simplify this. +5 plus or minus the square root of 25 plus plus 140 all over 14. Here we have x equals 5 plus or minus the square root of 165 over 14. 165, we can try and simplify that. Right, 165. So what number is the easiest to take out? It ends with a 5. A 5? That would be a 33 then, right? 33, we can 3 and 11. Since they're all prime numbers and there's no pairs, that's it. My answer would just be this. There's nothing to simplify here. Okay. Does that make sense, class? Because 5 times 3 times 11, that is 165. But since there's no numbers that I can take out, I'm good. Yes. 140 plus 25 is 165. Okay. All right. It already equals 0, so we're done with our first step for example 7. Yeah. And then now what can I take out? What can I take out of a 3x squared and a 6x? What's in common? What can I factor out? First, the numbers. 3 and a 6. A 3? How about the variables, x squared and an x? 1x, right? So if I divide everything by a 3x, what is left over? 3x squared divided by 3x is x minus 2. So 3x times x minus 2 equals 0. So 3x can equal 0, or x minus 2 can equal 0. So then if I divide this by 3, divide this by 3, I'm going to get x equals 0, or add 2, and then x equals +2. That makes sense? So where's my vertex of this parabola? 1. Right? Because remember our parabola, yeah? And these are my x-intercepts at 0, 0, and 2, 0, right? And since right in between will be my axis of symmetry, and somewhere along that line of x equals 1 will be my vertex. All right? Okay. It equals 16, yes. But what else do you see here? What can I do? This is where the rules or the steps would go right out the window, because then it's the easiest if I just square root this right off the bat. Okay. So x minus 5 would equal plus or minus the square root of 16 is 4. Add 5 to both sides. Then we would have x equals 5 plus or minus 4. Remember, when we were writing this, we need our plus or minus in between the two terms. Okay, so it's easier to understand. Okay, so x equals 5 minus 4, which is 1, 5 plus 4, which is 9. All right, so it's 1 and 9 as your answers. Last one of the day. This one's a little bit different from number 8 because it equals x. Okay, so you see the two variables, right? One variable here, one variable here. Yeah. So this one is a little funky. So what I'm going to do here is I'm going to expand this guy out, my left-hand side. If I expand it out or I multiply it out, we can use our special form or just FOIL it out or just multiply this out. If I just multiply this out, then 2x times 2x is 4x squared. 2x times negative 1 is negative 2x. This negative 1 times 2x is negative 2x. Negative 1 times negative 1 is positive 1. So my left-hand side, I broke this down to be 4x squared minus 4x plus 1 equals x. Right? And then I'm going to make one side equal to 0 by subtracting x on both sides. So then this will be 4x squared. Negative 4x minus x, that's negative 5x. Plus 1 equals 0. Okay, we're going to try and factor this. Getting the multiples of 4, that's 4 and 1, or 2 and 2. Getting the multiples of 1, that's 1 and 1. Using this combination of numbers, we're going to try and get the sum of negative 5. Right? And remember, it's always going to be plus or minus. Even though I don't add this every single time, it's always going to be plus or minus. We can always, negative times a negative is a positive. Okay, so I know I got to use the negative version. Why? Why do I have to use the negative versions of these numbers or some of these numbers? Yeah, because my sum has to be a negative number, right? So it must be a combination of negative numbers up here. Does that make sense? Yeah, to get the sum of a negative number, I need to add negative numbers. So negative 4 times negative 1 is positive 4. Negative 1 times negative 1 is 1. That doesn't get me a negative number. What two numbers do I use? -4 times +1. I'm going to try this one. +4 and +1. -1 and -1. -4 times, or +4 times -1, that's -4. +1 times -1, that's -1. So we do have -5, right? And whenever you're encountering this class, it's essential to keep whatever the x squared number is, the 4, as positive. Okay, so if you have to switch anything, switch the back number to negative. All right. So it'd be positive 4x times -1, and then positive 1x times -1. So then we have 4x minus 1 times x minus 1 equals 0. And if I make each of them equal to 0, then 4x equals +1, x would equal 1/4. Here, x would equal +1. Those two guys are my answers. That's the lesson for today, class. Okay.